Okay, guys, thanks for joining. Welcome to the Introduction to Python Programming class. So in this class, we'll talk about a few things and just get started. So at first, this is the introductory class. So, but we'll start with the computer programming basic. So in today's class, at the end of today's class, maybe we will only touch about how to start Python. But before even starting coding in Python, we need some of the basic stuff. So we'll talk about those things in today's class. We will learn how computer program works and how to make them work, right? So because when you're trying to write something so that computer follow your instructions, so we need to understand how computer understand your instruction. Uh, One of the easy, most question I always asked that actually why Python, right? Because my first language was not Python, right? So I learned Python long time after actually I graduated from college. So, but Python is one of the easiest language to learn for starting in programming because for the case of Python, actually it's more like actually the English statement or English sentences. So if you know how to speak English, there is a very easier learning curve for you to actually get starting coding in Python. For other languages like C++ or actually Java, you need to know some other stuff too, even before starting coding. So it's one of the easiest language to learn. What about me? My name is Imran. I'm working as adjunct faculty for one university and also another Metropolitan Community College. So SNHU and Metropolitan Community College. I'm a software engineer by profession with more than 12 years of experience. I have an undergraduate degree and also graduate degree in computer science. I taught mathematics science classes to high school students almost 20 years back. So I'm teaching for a long time. And I taught undergraduate courses, programming, algorithm, data structure, discrete math internationally. So I taught in Asia, Africa, and also in USA. I was the teaching assistant at Louisiana State University from 2011 to 2013 when I was doing my master's in computer science. And I also worked some of the top tech companies in USA like Microsoft, Amazon, and Oracle in the last 12 years. So yep, I know a little bit of programming. So what we will focus on in this course. So the main thing is that we will focus on few things. This is a 4-week class, and in 4-week class, we basically, in today's class, we'll talk about the introduction to programming, how computer work, and how to start programming. Next class, we will write our first Python program. So basically, before next class, I want everyone to actually have your IDE set up correctly so that actually you can start working on the coding. And the only way you can learn programming by doing it. So you can watch the YouTube video, you can join all the lecture, you can get a graduate degree or whatever degree you want to get. But if you don't go and write down your program or figure out actually how to make it work, it will not going to be in your memory for a long period of time. So I would suggest get your IDE set up after today's class, and then from the next class when we will work on the programming part, focus on actually testing at the same time in your computer, right? Third class, we'll talk about Python data types, get familiar with different data types in Python. So basically string, integer, float, and how to use them in conditional logic. We'll talk about if, else, elif, those kind of thing. And also in the last class, loop and other data structure, we'll talk about some of the other Python inbuilt data structure, how the loop works, like while loop or for loop. And this is just introductory class for first 4 sections. So I want to give you more training material and how to become efficient in Python. So if you want to focus on learn by yourself, right? So I'll give you enough material so that you can go from there and then learn something after the class ends, right? So what is our objective in these 4 weeks? In these 4 classes, what we want to do actually, we want to formulate solutions by applying general problem solving principles. So if we are given a problem, how we can approach the problem. Basically, these will help you if you want to be interviewed in any of the tech companies. When you go for software engineering interview, they ask a lot of coding problem. They will give you a problem. They want you to solve it 30 to 45 minutes. So we will talk about how to grow, or actually how to understand those problem solving principles. We will also talk about how we can develop an algorithm so that actually you can figure out how to solve the problem using flowchart. And sometimes I'll also talk about the pseudocode. We'll go into detail when we are in the flowchart or pseudocode section. And when you're trying to solve a problem, we'll talk about how we can apply appropriate data types and what are the things you want to do using these things. And finally, we'll talk about how to devise correctly sequential selection and repetition structure, mainly the fourth class about the switch and also while and for loop, and get comfortable with coding and how to use online resources to become proficient programmer. For this class, we are following this textbook starting out with Python. You can take a look at the book in the online, or if you want to buy it. But so typically, I use this book for Metropolitan Community College Python class. So most of the slides are from that book. So, but yeah, so it's not necessary you need to buy the book. But so if you want to dive deep into the details, instructions, then you can go and get the book. For the fast class, actually, I'll share at least a few part of the PDF from the book. If you want to get started, you can start with python.org website, where you can actually go into in detail about the Python docs. So these are one of the online material you should follow if you want to be comfortable with Python. The other way, we'll go to, you can go to W3 Schools Python, where we have some of the training material for Python. And that's our website, techfinss.com. So if you want to learn more about what we do in the teaching and also the internship, you can go into there. So what about the class logistics? So computer science may seem difficult because there are so many things, right? But it's built upon pure mathematics, logic, and reasoning, right? So if you understand mathematics, how the number system works, how actually math works, if you understand how the logical reasoning works, computer science should not be a very difficult subject as it might seem like. Although it's a free class, we teach each class with equal enthusiasm, and we also prepare course content before the class, right? So don't think that actually we will leave out some of the stuff. So I taught this course for a long period of time, but yeah, I follow the same thing, same course material, and also same understanding when we teach this class. Yeah, please mute your microphone if you don't want to ask a question. So if you want to ask a question and then unmute yourself, right? You can also ask question in the chat section. And during this class, these 4 weeks, ask a lot of questions. That's the only way you can learn about new concept. So if you don't ask question, most likely what will happen, you have some sort of understanding that you think you understand the concept, but when you ask question, you get the answer, or actually other people ask question, then you basically figure out that are you comfortable answering those questions. And then we will have 5-minute break after 30 minutes for additional questioning. And I will stay after the call for a few minutes if you have any questions, if you are really curious or have any other questions. Anything before we get started to the course material? Take that as a no. Okay, so let's get started. So the introductory part, we'll talk about how computer works, right? The main advantage of using computer, because computer can be programmed, right? So it can designed to do any job that program tells you to. So if you can write some instruction to do some specific thing to do, and you know how to do it by yourself, then it's pretty easy to tell someone to do it, right? Good thing about computer is that it doesn't complain as long as you don't give is very hard or very processor consuming task, right? So it wouldn't complain like, oh, it doesn't want to work, right? So how computer works? So when we want to write something to make computer work, we need to write some sort of set of instructions that computer follows to perform a task, right? And commonly referred to as software. So as the internet and computer become ubiquitous, what happened actually, you use a lot of software, maybe hundreds of software in a day, right? So in your phone or actually in your PC, you might have 100 to 200 software all the time, right? But those software can be partitioned down to very small part of coding, which is called a program, small program. And who is a programmer? Because if you want to write some instruction to let computer do some stuff for you, then the person who is writing those instruction, design those software, those are called programmer. And sometimes it's also called software developer. So if you are learning this computer programming or taking this programming course, most likely I'm assuming you will be a software developer, one sort of another. Nowadays, with the advent of machine learning, large language model, and AI, there are a lot of interest with the Python infrastructure. So most of the data engineering part, data scientist, and also the research engineer, research scientist, they are also using like some part of the programmer um, responsibility. So you can also call them as a programmer. So when you are talking about like a program and also the programmer, there are a few other key parts in the base of computers. So in the computer, there are a few key things, right? So there are one, obviously the software, right? So software means what program we write using any of the programming language. But we need to know other part of the computer that's called hardware. This is basically the physical device that make up the computer. So what is the difference between hardware and software? So the easiest way to differentiate these two is hardware is tangible. So if you can touch anything, that's the hardware. If you cannot touch anything, that's the software, right? So hardware consists of the keyboard where you are writing, the mouse or screen what you are using, and might be your RAM and also hard disk, right? Input or output devices like secondary storage devices. Those are the things are called hardware. So inside the hardware, there is one part which is actually do all the processing tasks. So if you write some instruction to do some stuff in your computer, then the main part, which is process all this instruction, that's the called CPU or central processing unit. And if your computer doesn't have a CPU, most likely it will not work what it's supposed to do, right? And all the software you are writing or even the program you are writing, it runs on the CPU. And 1964, there's a large computer, right? So people used to need track to actually transfer a computer, right? But nowadays the CPU becomes like a few centimeters, right? So if you open up your computer, laptop, or anything, like you'll find the CPU is a few centimeter, and CPU is located on small chips. So if it's a picture of the desktop. So if you know what the desktop is, so inside the desktop you will find few of the other things, like you will see the power box where the power is connected. There is a storage device. There is a CPU. You can see this part is the CPU, right? So inside the motherboard, there will be CPU. There might be a GPU, and you can install RAM there too. So these are the few different things. You can also install secondary storage device in the left side in the screen. But when you are writing instruction, all the instruction takes place inside the CPU. And RAM is the main memory where you are actually all these things are stored when it's running. So what's called main memory? Main memory means the stores the program while program is running. So people get confused with the main memory and secondary memory. So if you have a RAM, so let's go back to the previous screen. This RAM is called the main memory because when your computer is turned on, it's executing some of the instruction. It needs to move all the code to the RAM to execute all these instructions. So RAM is the primary memory. But you can see a secondary storage device in the left side, which typically used to store when your computer is turned off. And RAM is also known as random access memory. And the main advantage of that, actually, CPU is able to quickly access data in RAM. So RAM is pretty efficient. So if you have something in your RAM, most likely it will be able to access pretty fast. This is called volatile memory. Why it's called volatile memory? Because all the things you are writing in RAM, or you are not writing, CPU is writing, it will be gone as soon as you turned off your computer. So make sure if you want to save something, you need to store that into your hard disk, right? The secondary device. And contents are erased when computer is off. What about the secondary device? The secondary device or storage is actually which can hold data for long periods of time. That's your hard disk, or it can be, in our days, it used to be a floppy disk. It can be something like a flash drive, right? And so programs, whatever you are writing, you want to store or save your file into the hard disk so that when you come back tomorrow or in the next class, you'll be able to actually get those program back and use it. So there are a few types of secondary memory. So one is disk drive, what is used to call the hard drive. Nowadays, you can buy actually solid state drive, which is faster than disk drive, and the flash memory like portable, no physical disk, right? So if you are comfortable or if you already know the flash drive. What are the input devices? I'm just going through these one pretty quickly because these are the basic things about computer, and it helps to understand how actually you need to figure out to start programming, right? So few of the key things are called input. Input devices are how you can actually give some sort of input to the computer. And basic examples of keyboard, mouse, touch screen, scanner, camera, those are the input devices. What about output devices? Output device where computer can give you something, right? So if computer has something, if you want to get that out from the computer to yourself, that's called output devices. It can be something like our monitor, right? So where you can see this screen. It can be a printer where you'll be able to print something. In the case of software, there are two different types of software. So everything in computer is controlled by software, right? So there are one software which is called system software, which controls the whole thing. So for this PC, this is the Windows PC, right? This PC is run by operating system. So that's called the system software. And the PowerPoint I am using to project this PowerPoint slide to this screen, that's called the application software. So let's go into detail about how computers store data, because this is really important, because if you don't understand this part, most likely you will be able to, in some difficult situation where you not understand what's the main problem or debugging a solution, right? So when we want to store something in a computer stores all the data using like bits, and bits means like 0 and 1. So all the thing you are seeing even in this monitor, or right, like this PowerPoint slide, all those things are stored as a series of zeros and ones. So 0 and 1, these are called bits. So you have two bits, and with the 0 and 1, we'll go into detail. For the 0 and 1, that's called binary number system. If you combine multiple bits together, like 0 and 1 together, and if you combine 8 of them together, that's called a byte. Just enough memory to store a letter or a small number. So for example, if you want to store just a B, right? B as a character. If you want to store a B, you can't store B with just 0 and 1 because 0 and 1 is only one thing, right? Only two things. So, but even for English alphabet, we have there are A to Z, 26 letters, even for caps and also the small letter. So there are 52 different combinations. So if you want to store just a character like B or Y or T or an A, you need 8 bits of character. That's called byte. And it's divided into 8 bits. So byte can be divided into 8 bit. So for example, let's look at this, right? I just write to the screen and you'll be able to see it. Yeah, I'm just writing here. Let me know if you can see it. So for the case of 0 and 1, so if you have 0 and 1, so these are actually two different part, right? So these are called bits. But if you want to store some large number, for example, any number like A is a character, or maybe from your number, maybe 101, right? Or maybe you want to store just 9. So there is no way computer can store these A as only 0 and 1, right? The problem is that you have only two different combination for 0 and 1, and A cannot be represented with 0 and 1 only, with only 2 bits. So what computer needs to do, it needs to figure out actually how we can differentiate these A to 9, right? So what does A means, what does 9 mean, right? Even for if you want to write capital A. So this is a different thing than your small a, right? If you write capital B, so this is different than actually the other, or small c or capital Z, right? So how computer store those value, we'll look into detail, but if computer want to store just only this capital A, it needs 8 bits. So something like this. And all these 8 bits, that's called a byte. And all of them will be 0 and 1, something like that. So for example, 9, if you want to represent as a bit, so basically these will become 1, 0, 0, 1, and there are 4 zeros. So this is your byte to represent 9. So bit represents two values, that's 0 and 1. And we'll talk about how we can store the values. And byte side limits are like 0 and 255. So what does that mean? That actually for a byte size, so if you have 8 bits, uh, the lowest number you can represent with 8 zeros, right? So 4 and 4. And the highest number you can represent basically so all 1. So there are total, if you just going through all the numbers, there are total 256 numbers from all the zeros to all the ones. That's why it started with 0 and the maximum number is 255. So with 8 bit, you can only represent 0 to 255. And if you want to know more, maybe we can go into detail at the end of the class. But so storing characters, so when you want to store all these characters like A, B, C, then in ASCII characters, there are total 128 characters, and it can store all the values. And let me just show you one of the ASCII character chart. Let me go to there and then. So if you look at this chart, see what is ASCII table. Come on. So as I was talking about a few things, right? So for example, if you want to represent like capital A, so this has some value, B has different value, and other characters have different values, right? So from the case of decimal, you can see you need to only care about these two numbers. So decimal is 65. So if your character is capital A, this is actually a 65. And you can convert this decimal to a binary number. We'll talk about how we can convert that one. And for small a, which is actually 97. So this is the ASCII table chart. So you don't need to memorize it, but it's always good idea if you know actually what does each of the character means, right? So this is small a, which is 97, and capital A is 65. So if you go to A to B, it will become 65 to 66. So, and you can take a look at capital Z is actually 90, and small z, which is actually 122. Few other characters you need to know, like a space in your keyboard. If you press a space, this is decimal 32. So the number wise is 32. And also you can take a look at zero. Zero is basically 48. So when you are writing programs, sometimes you need to know actually what's the actual value of that character, right? So although in the keyboard you are pressing zero as a character, as a number, that means 48 to the computer. And when you are pressing space, this means actually 32. And few other characters in the keyboard, you can take a look at the other part. Any question about the ASCII table? Okay, we'll take that as a no. So how a program works, right? So when you are writing something in your computer and you store that program in a computer, so most likely you will save it to your hard disk. If you write a Python program, and your Python program would be something like, let's start a Python program, right? So you can either use some of the VS Code. So I'll just give you an example, but you can start with any IDE. So this is VS Code, one of the IDE. So what you can do actually, you can just open up any of the file, right? And just write. I hope you can see. So this is your first Python program, right? So you write a program. This is also a valid Python program. You'll save it as, I'll save it as my document, in my document. So let's see. When you save it as a fast.python, right? So you store it as a Python file. We'll make it all files, right? So what happened when we store this file, like fast.py, in our document directory into the computer? So we store this file into a hard disk. So if we come back tomorrow, we'll be able to see it. But if you just start writing, for example, create a new Python program and you didn't store it, right? So hi. So I wrote a Python program, but I didn't store it. Right now it's in actually in your RAM. So what will happen actually, if you close this VS Code or close this computer, these will be gone. You'll not be able to find this file until actually you save it in your local memory. Nowadays, most of the IDE like Notepad or VS Code, they store it as a temporary location so that if you come back to VS Code, you'll be able to see it. But if you uninstall VS Code, you will not be able to find out this part of the code, whatever you wrote here, right? But this file, fast.py, you store it in our computer, we will be able to see or find this file tomorrow, or we can send this file to someone else if we need to. So when you are trying to execute a program, that program was stored in the secondary memory. It needs to be inside to the RAM if you want to execute it. So it was in your secondary memory. When you are loading this one and trying to run this code, it needs to be brought over to the RAM first. And what happens, so for example, if this is your RAM, like main memory, you can see there are a lot of 0 and 1, right? So let's talk about the steps by step, right? So you wrote a program, you store it in your secondary device. When you open it up in a VS Code or any of the IDE you want to execute that code, that needs to be brought it over to the RAM first. So now all of your code are in your RAM. Now in the RAM, each of the line means some of the instructions, and all of the instruction means some sort of 0 and 1. So how the computer program works, at first, it actually fetches the next instruction in the program, right? The CPU needs to bring over the first instruction to the CPU to execute it, right? So it bring the instruction to the CPU, it decode that instruction, that means which needs to be performed, and then it execute that instruction. So there are three phases, right? So first phase, it fetch the instruction, then it needs to know what needs to be done. If you are trying, so for the VS Code, we wrote actually in the Python program, print, this is our first Python program. So that's the instruction. It needs to decode actually what needs to happen in the computer, and then it will execute the instruction. Basically, if you run the code, it will print the line into your terminal. So a few key things to understand when you are learning Python programming. So Python is called interpreted language, where actually it goes line by line. So basically, if you write 10 lines of code, it will execute one line at a time, right? So first line, second line, third line, right? But if you are programming in something like C++ or C or like Java, those are called compiled language. In the case of compiled language, what it does, it actually convert all those things into a machine language. And for the case of Java, it convert it to a bytecode. So there are two different types of language. One is for the case of Python, which is called interpreted language, which basically convert or interpreted one line at a time. But when you are trying to compile like Java or C++, those are compiled into a different types of code first, even before running into the computer. And so when you are trying to write a code in your own language, for example, if I go back to our VS Code, this is the line what we wrote here, right? So this line, this is a valid Python program where I wrote print, and inside there is some instruction here, which is understood by any of the English speaking people, right? So people will understand. But computer doesn't have any idea what does this means, because computer doesn't know what does print mean. Computer doesn't know actually what this parenthesis mean or this actual double quote means, right? So these whole instruction need to be converted some sort of machine language so the machine understand it, right? So the CPU need to understand what does this means. So when you convert it to the machine language with 0 and 1, computer then can understand and execute this code. There are two other things. I don't want to go into detail, but there are a few other things like assembly language. So basically, in the assembly language, you write some sort of more close to the machine language. So whatever we wrote in the print, this is our first program in English in a Python file. That's called more high-level language. And there is intermediate language like called assembly language, where you use some sort of register knowledge, like which is close to the machine language, like close to 0, 1, but not exactly 0 and 1. And then the last part is some sort of machine language where computer can understand, right? And from the high level perspective, there are two different types of language. One is high level language where we wrote something like using Python, Java, or C++. So that's called high level language. And if you write something like which is close to machine language, that's called low level language. So assembly language is one of the low level language. And so when this decoding happens, like actually if you are writing something into your computer or actually in English language or in a Python program, it needs to be converted to different types of instruction which is close to the machine language. So there are a few other things it needs to understand, like for example, print is a keyword, right? Because when you write print, it knows actually what you are trying to do. You can write some other like if else or maybe while for. Those are different types of word, and it means different things to different programming language. So if you write if or int, it knows it means something, right? So there are a few keywords you need to know. So if you are working on Python language, you need to know actually what are the Python keywords. Same as like there are called some sort of operators. We'll go into in detail when we are going through the language one at a time, right? But to wrap it up, like keywords means actually there are some specific keyword you cannot write in your code because computer interpret those differently. There is also some sort of like operator, right? You can use and operator or operator like equal sign or plus sign, right? It means different thing for the computer. And statement means if you write a whole sentence, that's called a statement. Just give you a high level idea. So we wrote one thing like print. This is my first Python program. This is called a statement. And a statement can be multiple lines. If you can write 5, 6, or in a line number of lines. And we'll not go into in detail, but so just to understand how it works. So when you are writing a Python code, the interpreter will actually execute one line at a time. And what is called source code, whatever we are saving into our hard disk, that's called the source code. So we wrote, this is our first Python program, like the high level language. In the picture, you can see print hello something like hello world or hello Python. The interpreter will actually take that language and convert it to a machine language. And 1001, it will give it to the CPU, and CPU will actually execute all these instructions based on this 001. So that's how actually the level works. So why we are going into in detail, because some of the steps when you are, so yeah, if you just write like Python statement to print something, it's not that much necessary. But if you want to become a software engineer, or if you use Python for doing some interesting stuff or actually low level stuff, or if you want to work on the machine learning on AI parts, you need to understand how the whole instruction flow works. If you don't understand, basically, you will not be able to debug large program, right, or large software where there is a bug or there's something not working. You'll not be able to figure it out actually how to fix it, right? So that's why you need to understand what are the each step and where it might go wrong, right? So for example, if you have a Python program and you want to run it like in Java, right, or C++, can you do it, right? So most of the time you can't. Another problem is that when you use Python, Python is, since it's interpreted language, it's pretty slow, right? So if you write the same software in C++ or other language or C, it will be much faster. So you need to know how Python works and also the how other language works, so that you have some sort of idea how you can convert those part of the Python code to C++ or actually other language, so that you can make it faster. But so basic idea is that for the case of Python, Python is pretty easy to understand. So if you want to prototype something, you want to just build something, show it to the customer or client, or maybe just build something. If it works, your idea works, Python is a good language to start out, right? Then you don't need to set up everything for doing all the nuances. But as soon as you see that, oh, in Python it works, now if you want to make it faster, right? If you are writing a software for millions of customer or clients, then if you write that in Python only, most likely it will be slow and people might not want to use it, right? So then you need to understand, oh, how can I convert some part of the program or maybe whole part of the program to different language to make it faster. And if you want to use Python, Python must be installed and configured prior to use. And we will go into detail how you can install the Python. And then there are two different modes you can use Python. One is interactive mode. and I'll show you actually how the interactive mode works, and also the script mode where you can save the statements in the Python script. So basically you need to know two things to start coding in Python. One thing, actually, you need to install Python. If it's a Windows machine, most likely your software center or software store might have Python already. You can just click the get button. If you are using MacBook, you might already have Python installed. And also same as for the Ubuntu, right? You can just open up the terminal, you'll be able to use Python. For the Windows, if you don't have Python installed, you can get it from the website, and I'll share the site where you can get it. Next thing, actually, yeah, two different ways to use it. One is interactive mode, one is script mode. In the interactive mode, it's easy to test it out. If you want to just test out 1 or 2 lines of code, that's called interactive mode. But if you want to write maybe 10 lines of code or 20 lines of code, it's better to write in the script mode. And how to get started with the interactive mode, right? So to start, so for myself, if I want to start with the interactive mode, I can just write Python in my computer. And basically 2 ways to do it. So let's see if you can see it. So if I write, so I already installed Python, and I can see this screen in the Python. So if I open up this IDLE shell, right? So for you, you can go to, if you need Python, so you can go to python.org here. If you are in Windows machine, right? So you go to download, and then maybe download 3.13.1, right? So this is the latest version, right? So for Windows, you can just download this one and install it. When you install it, you will be able to see all the instruction. I will share this instruction file with you guys. This file I'll share with you. So this is actually a printout or maybe the scanned copy from the book, right? So these are the steps if you don't have Python already installed in your computer, right? So you go to this site, you download this part, and when you are installing, just make sure you add this checkbox, add Python 3.10. It might not be 3.7, it might be 3.10 or 3.11, but just check this box. If you check this box, then actually you don't need to add the Python manually to your path. So then you can go to your apps. You can open up this ideally shell window. That's when you get this window, what I was showing you. And you can follow this PDF file to actually how you can do this, right? So just follow this step. So if you do that, then you will be able to get this interactive shell. So what does this interactive shell means? It's telling you that is the Python part, which is 3.10, which is the version number. And this 3 arrow sign means it's ready to take instruction from it. So if you want to give it any instruction, it will be able to execute it, right? So same as like if you want to just do print hi or hello. So what basically I'm telling Python interpreter that actually I want to print hello Python. And these are the specific instruction. If you hit enter, you'll be able to see the hello Python. And you'll see this print is gone, right? So this print is gone. So basically whatever you are putting inside this code, it will be able to print everything inside here in the next line. So if it's printing hello Python, that means you already have Python installed, right? Or Python is working correctly in your computer. And so if you want to work on this part, a different part like save a file. So there are 2 ways to save a file. So one is actually obviously from this ideally you can save this file, right? Other way you can get the VS code where we wrote this Python file, right? We have the Python file here, and if you want to execute this Python file, you can go to the terminal. See if I can go to the terminal. And so I'll go to the documents, right? So if you wrote this file here, you will see if you have these files, right? This fast.py. And if you have this file, most likely you'll be able to see just Python and this file name. And sometimes it might be Python 3. You see, you just write this Python and then this file name, and it will execute the whole thing here. So that's how you actually execute when you are writing a Python code in a file. Okay. So any questions? So yeah, I will stop recording. And for the online who are watching it later, if you have any questions, feel free to put into the comment section.